Good morning. So this is the second video in your physics lessons. This one is changes in energy 1. I hope that the first one made sense and everything was fine with that one. So we'll crack on with the second one. So energy in changes 1. Today we're going to be basing around one of the energy stores that we looked at last time, which was kinetic energy, which is the movement energy. And we're going to be focusing today specifically on the kinetic energy equation, which is this one here. Half times mass times velocity squared. Now this is one of the equations that you have to remember for your GCSEs. It's not one that's going to be given, so we have to remember it. But before we do that, I just want to talk through what all of these different things are measured in, because if you understand the units, it makes understanding the questions a lot more easier. So the first one, kinetic energy. Well, all forms of energy are measured in joules, which is given the symbol J. So energy is measured in joules. Mass, in physics, we measure in kilograms. And velocity, in physics, we measure in meters per second. Now noticing that this is velocity squared, so when we're working out our kinetic energy, we need to make sure that we square our velocity as well. We'll get onto that when we do some practice calculations a bit later on. So it's really important to understand the units for all of these things. It makes being able to use the equation that much easier. Now, like all of your equations, okay, this one can be put into a triangle to try and make it a little bit simpler to understand, and especially a bit easier when we come to rearranging a little bit later on. So at the top of the triangle goes the kinetic energy, and then underneath that we have the 0.5, the mass, and the velocity squared. Now these are really helpful triangles if you're unsure on how to rearrange an equation. So what happens is, if you go down, that's a divide, and if you go across, then it is a multiplication. So for example, if you're trying to work out kinetic energy, you would cover up the kinetic energy, and whatever's left you do 0.5 times the mass times the velocity squared, just like we mentioned at the top up here. Now this comes into handy when we're trying to work out something like mass though, because it means we need to rearrange the equation. So what we do is we would cover up the mass, and we can see now where we do the kinetic energy divided by 0.5 times by the velocity squared. And obviously if we wanted to work out velocity squared, we would cover it up and we do kinetic energy divided by 0.5 times by the mass. We'll do more on that a little bit later on, but that's just an introduction. This is key. Okay, this is one of the equations that you have to remember. It's one of your 23 that you have to remember, so it's really important. And like I said, if we can start to learn the units of things now, it makes it that much easier a little bit later on when we are trying to learn all the other 23. So let's start with an example. Okay, so say I was trying to find out how much kinetic energy a body of mass 1 kilogram travelling at 4 meters per second. So how much kinetic energy a body of mass 1 kilogram travelling at 4 meters per second. So first of all, I need my equation. Kinetic energy equals a half times mass times by velocity squared. And this is how really you should set out your equations to ensure maximum marks in your exam. So first of all, we need to spot the mass. So mass 1 kilogram. 1 kilogram times by the velocity 4 meters per second. 4, and then the key thing with this is we need to do 4 squared. Work that out nice and simply. Put it in your calculator, because you would have a calculator for exam, and that comes out to be 8 joules. So as you can see, it's nice and simple. I've done the equation, I've subbed my numbers in, and then finally I've got my answer. Now what you guys can now do is you can stop the video, and if you have a look at all those questions, all of those 1A, B, C, D, E, F, G, H, I and J are all using exactly the same way that we just did them. A half times mass times by velocity squared to get the kinetic energy. And what I will do is at the end of the video, I'll put all of the answers to the questions on so you guys can have a practice. If you want to pause the video now and have a go at them, that's really good practice. Now what you could be asked to do is you could be asked to answer, instead of trying to work out kinetic energy, you might be asked to try and calculate mass. So for example, what is the mass of a car travelling at 16 meters per second with a kinetic energy of 48,000 joules? So this time I'm not trying to work out kinetic energy, I'm trying to work out mass. Well, we do the same thing as we did before. We start off by writing the equation, 0.5 times mass times velocity squared. But this time, we're obviously going to need to rearrange the equation. But the first thing we do is we sub in everything that we know. So first of all, kinetic energy of 48,000 joules. So 48,000 will go in there, equals 0.5 times the mass, which we don't know, times by our 16 meters per second, 16 squared. It's really important that we do this step and make sure that we sub our numbers in first before rearranging, because if we make a mistake at the rearranging, at least we've gained ourselves a mark there. Then we need to rearrange it. Well, if we go back to our triangle in the corner, 0.5 m and v squared, well, we're trying to work out the m, so we cover it up, and we do kinetic energy divided by 0.5 times by the velocity squared. So it's going to be kinetic energy, which is 48,000. It's going to be divided by 0.5 times by the velocity squared, and that's going to be our mass. Again, you can just sub this into a calculator, and when you do, your answer comes out to be 375 kilograms. So again, we've wrote the equation, we've subbed our numbers in, then we've rearranged, and we've got our final answer at the bottom here of our 375 kilograms. Now, just like before, okay, all of these here now, sorry, there we go. All of those, to A, B, C, D, E, F, G, H, I, and J, they are all using the exact same idea of calculating the mass, doing the exact same thing that we just did there. So if you want to pause the video now, you can have a go at all of those. And again, I'll put the answer at the end of the video. Now, the final thing that they could ask you to calculate through this is they could ask you to calculate the velocity. So for example, find the velocity of a car of mass 1,000 kilograms and a kinetic energy of 12,500 joules. So it's the same idea, it's the kinetic energy. We write down the equation first, we sub in the numbers that we know. Kinetic energy 12,500 equals 0.5 times mass of 1,000 kilograms times by velocity squared. We always do this step. We ensure we do this step, gets our marks. We go back to our triangle, kinetic energy, 0.5 mass velocity squared. We cover up the velocity squared, and we can see we've got kinetic energy divided by 0.5 times mass. So kinetic energy divided by 0.5 times mass, and that will give us velocity squared. Now the key thing at this step is we don't want the velocity squared, we just want the velocity. So we have to square root everything on this side of the equation to get our velocity. Again, when we sub that into our calculator, we get an answer of 5 meters per second. So I've wrote the equation, I've subbed my numbers in, I've rearranged, and finally got my final answer. And last time, if all of these questions, there we go, for the question 3A, B, C, D, E, F, G, and H, they're all doing the exact same thing. finding the velocity of those different objects from the mass and the kinetic energy. Now you will notice when you get to the bottom of these, some of them say mj and kj. We're not going to worry about those today, we're just going to practice rearranging using the equation, and again I'll show the answers at the end of the video. And that's everything for today. If you practice using this, like I said, making sure that you always write out the equation, always sub in the numbers that you know, you go away and you'll learn the units for everything, and you'll learn the triangle. This topic should be dead easy. Right, that's everything. So what I'm going to do is I'm going to quickly show you the answers to the calculations. So there's all the answers to question 1. You can check those. There are the answers to question 2. And finally, there are the answers to question 3. All of these are just from this book, GCSE Physics Bank Questions by Keith Stansby, if anybody wanted to go and buy that from Amazon. Right, that's everything. Thank you very much.